This is our second day of Chapter 2. We are still continuing sections 2.4, 2.5, and 2.6. And we're going to jump in right with a doozy. We're going to complete this 2-column geometric proof. And this is way longer than almost any proofs we're going to do. I wanted to make sure we saw a big variety of things that can happen. So let's start. With a 2-column proof, we are going to be something that's given, one thing or many things, and something to prove. And there will sometimes be a diagram to go along with our problem. So this one gives us 1, 2, 3 different things. And we can either choose to put all the given statements right at the top, or we could spread them out and save them for when we're actually going to use them. And that's what I've done in this proof. So the first thing I'm going to do is I'm just going to list the things that are given over here, so that way once we get to that step later, we're not confused as to where it came from. So HK bisects segment JL is right here. X is the midpoint of segment HK is here. And HK is congruent to JL is here at step 13. So those are all my given statements. So anytime something is given to me, I'm going to list the reason as given. The reason I'm not putting number 17, segment HX is congruent to segment JX is given, is because it's listed as prove. That's ultimately what we're trying to get to, so it wasn't told to us, even though we know that's where we want to end up. So it's not a given statement. So I'm going to start here. If I know that HK bisects JL, if I think back to what the word bisects means to cut into 2 equal or congruent pieces. And what they're telling me is that if I'm bisecting JL, that these 2 pieces of JL are the same, that is the definition of bisect. And a pretty big hint or tip is anytime you see a word, either the reason you're going to use for that statement or the reason immediately after that statement will be the definition of that word. So this is the definition of bisect. Step 3 has the same exact letters as step 2, but in step 2 they had the bars with the congruence. In step 3 we're missing those. So we changed from congruency to equality. And if you remember from our last lesson, that is the definition of congruence. No matter which direction we're going, congruent to equal or equal to congruent. And now step 4. I have JL equals JX plus XL. I can't look to the previous step there because JL was not in it, or any previous steps. So step 4, I'm actually going to look at the picture and see if there's a reason that we wrote this. So we're saying that this whole length JL is equal to the sum of JX and XL. We're saying the whole segment is equal to the sum of its parts. If you recall from chapter 1, that is called the segment addition postulate. And I did mention back then that these were going to be incredibly important once we start doing our proofs. Step 5 looks very much like step 4. The JLs are exactly the same, the JXs are exactly the same, but instead of XL, I have JX. JX and XL are thought to be equal, so that means I'm able to replace one with the other using substitution. In my next step, I still have my JL, but instead of having JX plus JX, I have 2 times JX. So what I've essentially done is I've combined my like terms. So we can call this simplify, right? That's our catch-all term for all things reducing. And now we're at our next given statement. And I see a word in this given statement. X is the midpoint of HK, and now I'm saying that HX and XK are congruent. So I'm going to use the definition of this word, definition of midpoint, for why I'm allowed to do that. Come on, get rid of that box. Okay. So just like before, if I had the segments being congruent and now their measures are equal, we're going to call that the definition of congruence. And we're going to notice a pattern here, and sometimes proofs are going to do this. I now have HK equals HX plus HK, plus XK. So I'm saying the whole segment HK is equal to HX plus XK, so that's segment addition postulate. I then have the same exact thing, except xk turned into hx, so we substituted it in, and I know it was allowed to happen because hx and xk were equal in that step there at 9. And I've combined the two x's together to make 2hx, so that's again simplify. And we get to yet another given statement. Then I switch it from congruency to equality in the very next step. So we have another definition of congruence. And hopefully you can see why you're going to be rock stars at this particular reason. Here is where it gets super tricky. So I have this statement here, and I recognize that I've seen 2 times hx before. I saw 2 times hx right here. And I've seen 2 times jx before. I saw 2 times jx way up here. But they're not equal to the same thing. So we're going to have to go one step further. hk and jl are equal in this step. So we are still linking together the 2 times hx to hk, hk to jl, and then jl to 2 times jx. So one big transitive property. So usually I won't combine my transitives like that, or I shouldn't say usually. Sometimes I won't combine, sometimes I will, especially if the proof is really long. I'll combine them just to save a step. We could have done this as 2 separate steps and would have been fine. Going from 2 times hx equals 2 times jx to getting rid of the 2's. So we've essentially divided both sides by 2 using the division property. And the very last thing, I'm now changing them from equal into congruent, same exact letters, definition of congruence. And congratulations, we've done our first 2-column geometric proof. You can try this one, much shorter. Try answers are posted online. Pause if you were going to try it. Unfortunately, many times you will not be given the steps for a proof at all. And in that case, we're going to have to write the whole thing from scratch. Sometimes it helps to know what you're looking at to prove on the picture, and that will kind of help guide you in which way to go. So I'm starting out knowing that AB and CD are the same. I want to prove that AC and BD are the same. So I do notice that AC and BD overlap on segment BC. So that's going to have to come into play somehow. Terrible line. So I'm going to start with what I'm given. Segment AB is congruent to segment CD. And since I know I'm going to have to create additional segments in this problem, using most likely the segment addition postulate, I'm going to need things to be in terms of equals instead of in terms of congruent. So that's actually what I'm going to do next. I'm going to take this step here and make them equal to each other instead of congruent to each other. And we know that that's called the definition of congruence. And now I'm kind of stuck, right? I can't go any further with AB equals CD, so I'm going to have to introduce some new information to the problem. So I'm going to introduce segment AC is equal to the 2 parts that make up segment AC. That's AB and BC. Segment addition postulate. And if I look at what I have right now, AB is the same as CD, so I can replace the AB here with the CD. So I'm going to do that. Substitution. So we still don't have BD in the problem, and we know it has to get there by the end. So I'm going to do the segment addition postulate for segment BD. So BD is really made up of CD and BC. So if I look at steps 4 and 5, I might notice that both of them have CD plus BC in them, which would mean I'm able to link together AC and BD to each other because they both equal the same exact thing. It doesn't matter that what they equaled was being added, it was still exactly matching. So I can use transitive to link those two things together. And now I'm almost done. This looks very much like what I want to prove. The only difference is this is in terms of congruence while this is in terms of equals. So I'm going to change it. And we're using the definition of congruence. And that we just wrote from scratch a 2-column proof. So the last one is another try. I would highly recommend giving it a shot. Answers are posted online. And that is the end of our lessons for Chapter 2.